Hello everyone, Engineering Statistics and Linear Algebra. In this video, we will discuss definition and properties of determinants. Here definitions of determinant is written, just I do read here, later I will tell you how to calculate a determinant of any matrix. Let me read the definition. For n greater than or equals to 2, the determinant of an n cross n matrix A, that is a matrix with I rows and j columns, is the sum of n terms of the form plus or minus a of 1 comma j into determinant of a of 1 comma j with plus and minus signs alternating, where the entries a11, a12 and so on a of 1 comma n are from the first row of the matrix A. In symbols, a determinant of A equals to a11 into determinant of a11 minus a12 into determinant of a12, alternating plus and minus sign, so that here it is minus and here it is plus and so on. So in general, a determinant of n matrix A of order n cross n can be determined using this formula. It is a definition of an determinant. So how to calculate it mathematically? Consider n matrix here. Here a symbol of n matrix. A determinant of that matrix is denoted with this symbol. So a determinant of that matrix can be calculated using this formula, and as a result we do get a into d minus b into c. The first property of a determinant of the identity matrix is 1. These two are the examples of an identity matrix of order 2 cross 2 and order 3 cross 3 and so on. So always the determinant of any identity matrix, then it is always 1. Second property, the determinant changes the sign when two rows are exchanged. Consider the same problem here. For this value, a determinant is AD minus BC. Interchange the rows here, that is R1 should be equals to R2 and R2 should be equals to R1. Then calculate the determinant, that is equals to a minus of the first value. As a result, the determinant changes the sign when two rows are exchanged. The third property, the determinant depends linearly on the first row. Let us divide this property into two, that split into two operations, that is adding the vectors and multiplying by a scalars. First, add the vectors to the first row. Here for the first row, vectors a dash and b dash are added. It can also be written as a sum of two vectors here, sum of two matrices. Then the second linearity property, if the t is multiplied to the first row, as a result whole matrix is multiplied by, whole determinant is multiplied by an value t here. It is a third properties of a determinant. Then fourth property, if two rows of a's are equal, then determinant of a is 0. Row 1 and row 2 are equal here, then determinant of that gives an value 0. Fifth one, a subtracting a multiple of one row from the another row leaves the same determinant. Consider here the matrix. The row 1 is subtracted with the multiple of row number 2. A is subtracted with a multiple of row number 2. That gives the same determinant. It is a fifth property. If A has a rows of zeros, then determinant of A is 0. You can observe here. If any one of the row of a given matrix is 0, then the complete determinant will be a 0. Not only row, if any row or a column is 0, then the determinant of such matrix will be 0. Seventh property, if A is a triangular, then determinant of A is a product of A11, A22, and so on ANN. We can observe here these are called as a diagonal entries. If the triangular A has ones along the diagonal, then the determinant is only 1. We'll come to know what do you mean by triangular vectors, what do you mean by an upper triangular matrix and lower triangular matrix. If it is an triangular matrix, then determinant will be a product of only a diagonal elements. Then if A is a singular, then determinant of A is 0. If you want to say that the given matrix is singular, then its determinant is 0. If the given matrix is singular, then it is non-invertible. If the matrix is invertible, then it is non-singular. If you want to say that the given matrix is invertible, only if the determinant of it is non-zero. It is not equals to a 0 here. A singular matrix, it is non-invertible only if its determinant is 0. The ninth property, the determinant of A and B, the product is the product of determinant of A times the determinant of B. Here the one matrix, it is a product of two matrix. If you take its determinant, that is an product of individual determinant of A and B, that we can observe here. We see the 10th property, the transpose of A has the same determinant as A itself. Transpose means interchanging rows and the column. In both the cases, determinant will be same here. It is a determinant of A, it is the determinant of transpose of A. Both are one another same. Alright, these are the definitions and the properties of the determinant. We do see in the next video with the different concepts. Like, share, comment on the video, and don't forget to subscribe the channel. We see you in the next channel. Thank you.